We are in Algebra 2 on this beautiful December 5th, 12-5. Let's go ahead and make a note 12-5. I noticed that a lot of people are not putting their name on their notes, and some notes have been left behind. I don't know who they belong to, but make sure you're putting your name every single day. Factoring squares. So there are 3 assignments to do tonight. One of them, the first one is super easy. I don't even need to talk about it. The second one is doing difference of squares, and that third one is doing binomial squares. So we're talking about 2 topics today, but there's 3 homeworks. Just a heads up, there is a lot of work to do tonight. But I don't think it's that hard. I would give it a 3 stars out of 5 stars in terms of difficulty. All right, so this is a review, and James just did this not too long ago on his test, I think, or maybe it was slightly different. But if I have conjugates, again, these, I guess I should have asked that, but these things are called conjugates. Is there a quiet raised hand with the participation card? Why are they called conjugates? What about those make them conjugates? Why are they conjugates? Something to do with how they kind of parallel one another, but there's a slight change. Do you remember what conjugates are? No quiet raised hands? Conjugates. Going once, going twice. All right, no hands. Conjugates just mean you have the same binomial, but a switched sign in between. So Andrea, you know, I thought it was a cell phone for a sec, but it was a participation card. Again, if you have any cell phones, they should be up on the wall. There's 2 up on the wall already. Conjugates, they have the opposite sign in between them. How do I multiply these out? Do we remember how to do this? What do I do? Quiet raised hand with participation card. What do I do? There's 2 ways that we know how to do this. Gio.
Multiply A times A.
All right, so you're doing the FOIL technique. All right, so we're going to do the FOIL technique. So Gio, you want to do those first 2, and then someone else can get the other 2? A times A is? A squared. And then this A times the negative B is? Negative AB. Perfect. Hand in your card, please. And coming over here, Geo, there's your XP. All right, next 2, I'm going to do B times A. What is B times A? Quiet raised hand, Eva. Positive AB. And Eva, what is B times B? B squared. Negative B squared, you're right. Oops, yeah. Forgot the other arrow. And then minus B squared. Eva, turn in your card, thank you. All right, and then how do I simplify this? How do I write my final answer here? This is now equal to what, Fiona? Minus B squared, there it is. And then we would box that answer. Thank you, Fiona. You can turn in your card. Yeah, isn't that kind of cool? So whenever I multiply conjugates, I always get A squared minus B squared. And this is a review from our last unit, Unit 3. So we have, like, if it seems familiar, that's why it was in Unit 3. But now we're going backwards. This whole unit is about going backwards. So whenever you see 2 squares, and by the way, there's a giant list of squares up here. What is 14 squared? It's 196. So if you see any of those numbers on my square list up on the wall, that's a square. If you see x to the 6, that's technically a square because it's x to the 3 squared. Anytime you see 2 squares, and let's go ahead and label these. These are both squares. That's a square, and that's a square. Those are both squares. And you see a minus sign in between them because that's the definition of what we're doing. We're doing a difference, not a sum, but a difference of squares. Whenever you see 2 squares with a minus sign in between, they will always factor this way into conjugates. So we just have to rewrite the original problem, which is A plus B times B minus, or it's not B minus A minus B. It's the same binomial, but a sign in between that's switched. And notice the key thing here. I started with A squared, and each of these has a normal A in it, which means what I'm really doing is I'm square rooting whatever thing I had here. And I just want you to draw this symbol as a note to yourself, this symbol, this square root symbol as a note to yourself to say, hey, you need to square root whatever that square is in order to get to the term over there. Same thing for the B squared as well. If you want to do a symbol over the B squared as well, maybe that'll help you. But you always need to take the square root of whatever you're given for your square. All right, we have four examples of a difference of squares. So you already know that there are differences of squares, but next year and the years beyond, whenever you're doing higher levels of math, these pop up randomly, and I'm gonna be like, hey, remember 2 years ago when we did difference of squares? You do need to know this. This always trips up AP Calculus students, at least one of them a year. There's random difference of squares and they forget how to do it. Make sure you know how to do that. I know that there's gonna be 4 of us that are gonna be in AP Calculus. That's gonna be Fiona, Eva, Andrea, and Chris. I think you guys are all, and Steph, are you going in there too? I think you guys are all, so it's 5 of us that are gonna be in AP Calculus. You will be needing this later. All right, so factor completely. I'm going to do the first one with you guys, maybe the second one with you guys, but eventually you're going to be able to do them on your own. So when I'm factoring 36x squared minus 49, does anyone want to take a shot at what this factors into? It's 2 binomials. Raise your hand with a participation card if you have it, so I know who to call on. No one with a participation card is able to know how to do it. Do you have a participation card? Not yet. Andrea, do you have your participation card? Yeah, go for it.
Would be 6x plus 7.
6x plus 7 times.
6x minus 7.
There it is, yeah. Good job, Andrea. There it is, because 36x squared, when I took the square root, I'm really taking the square root of the 36 and the square root of the x squared. That's how square roots work. They're kind of, they're multiplicative. You can separate them if they're being multiplied. Square root of x squared is x. Square root of 36 is 6. Square root of 49 is 7. 6x and 7, those are your 2 terms. And then you have to do the conjugate. Let's see if someone else can do example 2. Someone that still has their participation card. Who wants to do number 2? James.
8x plus 10 times, or like, yeah, and then 8x minus 10.
You're really, really close. There's a tiny little error that you're making. Do you see it? I'll give you a hint.
Y.
So what about the y?
It would be 10y.
10y. Yeah, there it is. Good job, James. You got the points for catching it, even though I know you got a little whisper behind you. So correct answer, and James, you get correct points for finding the student error. Yeah, there it is. Let's try another one. Quiet raise hand. How do I do this next one? I currently have 5 participation cards, which means there's still 3 out there. 3 people. Someone's going to help me. I'll give you a hint for number 3. 12 is not a perfect square. It's not on that list up there. There's no, there's 12 squared, which is 144, but the 12 is not a perfect square, which means I need to factor something out. Something that's the greatest common factor of 12z squared and negative 27. What can I factor out of both of these? What's the greatest common factor? I'm looking for a card that I can call on. You have your card still? Yeah, go for it, Teflon.
3.
Yeah, so tell me how to write this. I'm factoring out 3, so 3 times the quantity of
4 plus 9.
Careful, you made 2 mistakes. I can circle the mistakes in 2 seconds if you don't see them.
Is it minus 9?
It is minus 9. So come back here, minus 9, and here's your other mistake. Yeah, there it is. 4z squared minus 9. We factored out a 3. Perfect. Thank you, Teflon. Turn it in. All right. Hey, by doing that, by factoring out that greatest common factor of 3, now that's a square because 4 is on my list. 9 is also on my list. These are now a difference of squares. Now it is a difference of squares. That's what we're studying right now. So now that it's a difference of squares, this now turns into, well, I still have my 3, so I'm still going to write that down. I still have my 3 outside. And then what do I have on the inside? I have 2 binomials. How many cards do I have? I'm missing 2 cards. So 2 people can participate here. I need to factor 4z squared minus 9. I know Chris is one of those people. Who's the other person? So Chris or Stego, yeah. One of you 2 needs to participate right now before anyone else can participate. How do I factor 4z squared minus 9? I'm going to have to cold call on one of you and put the pressure on unless you want to do it on your own. Sego, go for it. Say again? You don't know? All right, so the key point here is I need to square root the 4z squared, which is the same thing as doing the square root of 4 and the square root of z squared. What's the square root of 4? This is to you still, Stego. 2? Okay. And what's the square root of z squared? Z, perfect. 2z. Now I need to do the square root of 9. 3. Oh, so you want to do negative 3. That's fine here. It's negative 3. And then what's the other binomial? You have 2z minus 3, so the other one must be... There it is, yeah. 2z plus 3. You can turn in your card. That means, Chris, you're getting the next one. All right, Chris, find the greatest common factor. These obviously are not perfect squares because I have an 80 and I have 125. Those are not perfect squares. What is the greatest common factor of 80w squared and negative 125? What goes into both of those, Chris? What do you see? Take a guess. You got this, Chris. I believe in you. Think about not the variable, just 80 and 125. 80 and 125. What number goes into both of those numbers?
5.
There it is. There's our greatest common factor, 5. All right. Chris found the greatest common factor. Someone else help us out. What happens when we divide both of those things by 5? Everyone can participate now because all of our cards are in. Go for it, Fiona. Minus 25. And hey, look, by factoring out that greatest common factor, we have 2 squares. Cool, cool. So when we do that, I still have my 5 out front. Don't forget the 5. Whenever you factor a term out, it stays factored out, but it's still there. It doesn't disappear. 5 times, and then there's 2 binomials here. What are those 2 binomials? Quiet raise hand. Eva. 4w plus 5 and there it is. Thank you, Eva. And there's our final answer. And I haven't been boxing these, so let me come back here and box our final answers. That's the final answer. That's the final answer. That's the final answer. And that's the final answer. All right. Cool. So that's half of today's lesson. Half of it was what happens when you have a difference of squares. Key point here that's going to be in your summary, make sure you factor out the greatest common factor if there is one, and then after that you take the square root of each of those terms to write a pair of conjugates. Let's move on to the next half of today's lesson, which is binomial squares. So help me out. When I square something, do you remember the little nursery rhyme that I read to Riley, or that I sing to Riley? If you don't remember it, I will show you the pictorial version. Teflon, go for it.
Square the first, double product, square the last.
There it is, yeah. Say it louder one more time.
Square the first, double the product, and square the last.
Yep. Square the first, so this is a squared. Double the product. So the product means the product of a and the product of b. I'm going to multiply those two together. A times b is ab. And I double ab, so it's 2ab. So I'm going to add 2ab. I squared the first, I doubled the product, and I'm going to square the last. So square the last, that's going to be b squared. If you do not like the rhyme because of whatever reason, maybe it's just hard to remember, maybe you don't like that it's used to do mental abuse to humans at a young age, Chris, then you can make this other shape. You can do this one. And this is totally optional to add in your notes. You don't have to add this right now. You can do a plus b like this, a plus b like this, and you make our tabular multiplication grid, or our square. We do a squared, a times b is ab, a times b is ab, b times b is b squared. I add all of these up. I have 2 of these ab's. That's where this 2ab came from, and I also have an a squared and b squared. That's where all of this comes from. This is the tabular view of the multiplication. A good picture representation. What's going on, James? All right. So what that means is if I see something of this form, and by the way, this form is much harder to see than the forms up here. Difference of squares is pretty obvious because they're both squares. This one is a little bit harder because you have to not only see two squares just like before, but you also have to say, okay, if I square root both of those, multiply them together, and multiply by 2 to get that middle term, that's the middle term. These pop up less often in normal mathematics through the rest of your career, but they still do pop up. Not as important in my opinion, but you're learning them today. So if you see something of this form, and we're going to see examples on the backside in a sec, then it is equal to what? How do I factor it? It's very similar to what we just did back here. Oh, we started up here, so therefore this is equal to what we started with. If we started with this up here, this stuff is equal to what? Quiet raised hand. Geo. A plus b and that whole quantity squared. Thank you, Geo. All right, we're on the back side. I should hear your paper flipping. We have 3 more examples, 5, 6, and 7, and we are done. I will give you this hint. Because I gave you an example, it is of the form of a binomial square, where it's a squared plus 2ab plus b squared. You don't really have to think about it too much, aside from the fact of how do I figure out how to factor it. Generally speaking, on Khan Academy, if you see 3 terms that look weird like this, it's going to be a plus b squared type of form. All right, so how do I factor example 5? What am I going to do? And my hint is ignore the middle term. Just look at the first term and the last term because we need to get to a and b. I just have to square root the first term, square root the last term, and I can get to the factored form. With that hint, how do I factor 9x squared plus 48x plus 64? Same 2 hands over and over again. Andrea, go for it.
Wait. Can I say it?
Go for it, yeah.
3x plus 8 squared.
3x plus 8, that whole quantity squared. You have it. The end. Good job. And this came from 9x squared. We square rooted that. The square root of 9x squared, well, you do the square root of 9. That's 3. The square root of x squared, that's x. That's the first term. And then it's going to be a sum of squares, or not a sum of squares, but it's a binomial squared, which means I'm talking about the second term. I just need to square root that. That's my second term on the inside of the factored form. Just square root the first term, square root the last term. That's all we're looking for. Did I give you your XP? I did not. All right, so number 6, example 6. Who wants to factor this one for us? Eva.
6 plus
5x plus 5x quantity squared. Yeah, that's right. And just to make sure that it's right, this is what we can do, and you can do this in your head, you can do it on paper. You can say, okay, well, if I multiply those two, do I actually get the middle term? 6 times 5x is 30x. If I double that product, if I double 30x, I do get 60x, so it does satisfy that form. Our final example before we write our summaries and then move on to the homework. Who wants to do example 7 for us? Example 7. By the way, example 7 is very similar to example number 3 because you have to factor the greatest common factor out. That's why it doesn't look good. If it doesn't look good, you have to factor something out. Example number 7. Someone's raising their hand to tell me what the greatest common factor is that I can factor out of this guy. I can see. I see one hand. I need to see more hands before I call on someone. What is the greatest common factor of all of these 3 things? I see 3 hands. One more hand, kind of a geo. We'll give it to Fiona. 3. And when I factor out a 3, Fiona, what is left on the inside? Did you already do that? 16y squared plus 8y plus 1. Yeah, thank you. Yeah, and that's hard to see because I know that not all of us are comfortable with dividing 48 by 3, but there it is. And hey, look, I have a square here and I have a square here. By the way, 1 is a squared because 1 squared is 1. So I have two squares on the outside, and if I take the square root and multiply them and multiply by 2, I do get 8y. We still have the same form that we're looking for, this form right here that we've starred. Therefore, let's go ahead and apply our factoring technique to example number 7 to finish it off. What's my final answer? I see one hand. I only see Fiona's hand so far. I still only see Fiona's hand. I see Gio's hand. I want to see one more hand before I call on someone. How do I factor 16y squared plus 8y plus 1? Essentially, you square root this term, square root this term. That's the basics. I need one more hand before I call on someone. Where is that one hand going to be? There's that one hand. Gio.
3 parentheses 4y plus 1.
There it is. Thank you, Gio. Are there any questions about this lesson? Questions, questions, questions? No one has a question? All right, that concludes our lesson. Make sure that you have a nice, thorough summary, maybe something that talks about how you need to maybe factor out the greatest common factor if you ever get stuck. Like if you see 12 or some number that isn't a perfect square, it probably means you need to factor out the greatest common factor. And there's one key thing that I never talked about today, which is a sum of squares. If you ever see the form a squared plus b squared, that's impossible to do until next year. Next year, we'll learn how to do that. All right, that concludes today's notes.